Ever since Alexander Fleming's discovery of penicillin in 1928, antibiotics have been used to treat most, if not all, bacterial infections. However, in recent years, the bacteria that were once easy to eliminate have developed a tolerance for these once useful antibiotics. So how do these antibiotic-resistant bacteria come about? Well, first we need to see how antibiotics are supposed to kill bacteria. There are 3 types of antibiotics that kill bacteria, but for now we will only focus on beta-lactam antibiotics, the most commonly used variety. Beta-lactam antibiotics, such as penicillin, target a bacterial enzyme which builds a network of carbohydrate and protein chains called peptidoglycan that is used to make a cell wall. This happens because the modular pieces of the chain and penicillin share similar shapes, causing the enzymes to bind to the penicillin, thus giving the enzymes the name of penicillin-binding proteins. Without peptidoglycan, the bacterium will burst due to the pressure caused by the high concentration of proteins, small molecules, and ions within its cell membrane as compared to the very small amount in the surrounding environment. Let's see how they can develop antibiotic resistance. Bacteria have developed many tactics to become resistant to drugs like penicillin. The most common and effective way, however, is the creation of a new enzyme called beta-lactamase, which targets penicillin and deactivates it. Thanks to evolutionary modification, more and more bacteria have developed to have this enzyme, since those with it are more likely to survive than those without it when faced with antibiotics. A typical penicillin-binding protein uses the amino acid serine in its reaction. The serine forms a covalent bond with the molecules in the peptidoglycan chain, then releases them to form another link in the chain. Penicillin works by binding to the serine and preventing it from being released, which permanently blocks its active site. Beta-lactamase enzymes contain a serine amino acid, which attracts the penicillin. When penicillin binds to the beta-lactamase, however, it will become inactive. Now that we know how antibiotic resistance has developed, how are we affected by it and what can we do to prevent it? If antibiotics can't be used to fight off bacteria, we'll be vulnerable to many infections and diseases that could spread unchecked, hurting a lot of people. There would be no cure for these strains, and many of them, including ones that are potentially lethal, could quickly become widespread. Fortunately, there are some things that you can do in order to slow the process of antibiotic resistance. Don't use antibiotics for viral infections, like the cold. Antibiotics aren't meant for viruses. You shouldn't be saving antibiotics for the next time you get sick. Throw away extra antibiotics after the prescribed time. Only take antibiotics exactly the way your doctor tells you. Not doing any of these things could seriously hurt you and cause antibiotic resistance in bacteria. Antibiotics are a powerful tool that we have used and should keep using in order to save lives, and we should be careful not to lose the amazing advantage they offer.